Hello, my name is Ashley Kipp, and I will be presenting my proposal on remote sensing methods to locate archaeological sites through vegetation indices on the Florida coast. My partner is Dr. Lindsay Cochran, the archaeologist at Eastern Tennessee State University, who is working with the Iguana Talamato Matanzas National Estuarine Research Reserve researchers. This is just an overview of what I'll be going over in this presentation, the general problem, the background, my study area, the materials and methods used, my expected results, and any further research. The problem that archaeologists are facing are the effects of climate change, sea level rise, and storm surges. And with just 1 meter of sea level rise, over 13,000 documented archaeological sites will be lost. Like I said, those are only the documented ones. There are many more that we are not currently aware of, and there are not the correct funding or archaeologists available to do that level of surveying to help find those sites. Relative sea level rise compounds this issue, and that just means that there are local scenarios like on the southeast where the land is also sinking, so sea level rise rates are much higher in those areas. Now you could ask, why is archaeology important? And you ask anyone, they're going to give you a completely different answer. However, there is an intrinsic value that's been given to cultural heritage sites, archaeological sites, that the government recognizes and implements different strategies to help with, including the National Historic Preservation Act. With sea level rise, there's a lot of information that will just be lost forever if these sites are destroyed. Information about the past and information about the present that we can glean from that, how people affected their ecosystems and how they reacted to them over time. There are many, many different sides of value that you can take from an archaeological site. Now, GIS is heavily used to look at issues with sea level rise, and there are many existing models that both are just bathtub modeling, which just looks at elevation versus rise scenarios. And then there are more complicated ones, such as the sea level affecting marshes model that I have an image of on the side here. That takes in a lot of different factors, including land use and the vegetation in the area. And those can be used to find cultural resource vulnerability, and they're great for finding areas that are most in need of mitigation, but you also don't necessarily find site locations that we are not aware of that may be being lost. That is not to say that archaeologists are not using GIS to help locate sites themselves. People can use light detection and ranging, which uses laser light reflectance to take points that can be used to create higher resolution ground elevation models, and aerial imagery. The images on the right reflect those two. On the top, there is a LiDAR derived image that locates shell rings. And on the bottom right there you have aerial images that are looking at crop or soil marks. And that's underlying archaeology that is affecting crops in a way that makes them visible from these aerial images. Those are actually showing Roman habitation sites. There's also site sensitivity modeling that can be used with various inputs such as historical information, site locations or potential site locations to streams, least cost paths, but there are so many inputs that can change those results. There are also many other studies that look at vegetation in particular in association with archaeological sites. One of those is one that was conducted in British Columbia that was looking at coastal forest productivity in connection with these sites, which I will talk a little bit more in the next slide. So what does tree health have to do with archaeology? Well, when there is a long range of habitation in an area, there's going to be a lot of refuse or just generally garbage. Now, in coastal areas, like the one that I will be focusing in, that can include shell middens, which is just basically a trash pile of the shells used after eating or for other activities that have been tossed out with other garbage or remains from fire or even locations where fire has been used to help maintain the forest throughout the past. Now, these things can add calcium to the soil, improve drainage, and it alters the soil pH. Now, calcareous soils and wood ash have been tied to increased vegetation health, basal width, growth rates, and infection resistance in vegetation. So this leads to my research question, taking in all these different uses. Can tree health indices and canopy height derived from LiDAR accurately locate archaeological sites in a mixed canopy of a coastal forest? My study area is the Guantanamo-Matanzas National Estuarine Research Reserve, which I'll just refer to as GTM from now on. It is located on the northeastern Florida coast in St. Johns and Flagler counties and consists of 64,487 acres of wetland and upland habitat with evidence of human habitation that ranges from Paleo-Native Americans from the late glacial period up to the popular homesteads and missions of the territorial period. For this analysis, I'll be using ArcGIS Pro. I downloaded 25 orthorectified National Agricultural Imagery Program multispectral imagery tiles from USGS, and those are at 0.6 meters per pixel, so it's very high quality imagery. I also downloaded an aerial LiDAR point cloud, which had already been pre-classified by the St. Johns County for the Florida Peninsular LiDAR project. And then I also used the GTM's boundary and habitat system layers that were collected from the National Estuarine Research Reserve System Centralized Data Management Office. From these downloads, I will be doing the Normalized Difference Vegetation Index Analysis, NDVI, to determine the vegetation health or overall greenness. I put the formula for this by that. It uses vegetation reflectance of near-infrared and red bands with a range of values starting from -1, which means no vegetation, to 1, which indicates very healthy, and values around 0.6 and above typically indicate health of trees. Then I will be finding the canopy height, which will be derived from the LiDAR download, and I will be doing that by converting the ground and canopy classifications from that pre-classified set using the LAS dataset to raster tool within ArcGIS, which will interpolate or create a continuous surface from the points to create a ground surface and canopy raster. Raster math will then be used to find the difference between those interpolated surfaces, which will result in that canopy height. So areas within the coastal forest in GTM that have high NDVI values and canopy height values will be shown and put into a final suitability raster layer. To do this, the NDVI and canopy height layers will need to be reclassified using the reclassify tool, and the top 10% of each of these values will be assigned as the same range of values for input into the modeler within ArcGIS Pro, and they will be given the same weight for the weighted sum part of that modeling. That suitability modeler will produce a raster layer showing areas most likely to indicate archaeological sites, and will further simplify this into either just a suitable or not suitable range for the analysis I'll speak on after this. All of these steps in geoprocessing will be completed within the model builder function in ArcGIS Pro to track project and be used later. Once completed, the known archaeological sites, which will be given to me by my partner, will be compared to the results of this model to test the percentage of accurately predicted sites. Further, a binomial test will be conducted to determine if the percentage of accurate predictions of site locations would be statistically significant as compared to a random sampling or a grid search. From this, I expect to have a model that accurately can predict the locations of sites based off of canopy height and vegetation health. And if it does statistically prove that, then we know that those are good indicators and predictors of site locations. Then the model builder workflow that I mentioned I've been building will have the ability to have inputs put in from any location and any archaeologist for use in their own area of interest to hopefully find sites in those areas as well. After the capstone is completed, my partner and I will go out to the location and actually test the places that the model may predict there are sites that are not correlating with already known sites. I can't do this right now because of the hurricane damage to the reserve. After that, also during this process, we hope to see if there's a correlation of tree type at these site locations, which can further aid in site identification. To conclude, we hope to find that vegetation indices can be used along with LiDAR-derived canopy height to accurately predict site locations, which would help solve the issue of not having enough funding and archaeologists to cover all of these areas that are at risk from sea level rise to find sites that we may not know of. So thank you for listening to my presentation, and here are my references.